And there's just a procedure to go through. You want me to keep talking, John, or do you want to keep running? He's getting there, so we've just got to enter some information. There's passwords to get into the test bench. And once we have the pump details in there, then we can record it. And then once that's done and recorded, then the head goes onto the pump, and then all the pipes are connected, and it runs through the process. Is this going to take up your whole day? Not here, I mean. The milk bar down the road.
Absolutely.
There's an external power supply for the processor, which John, there's steps. The test bench asks you to turn the power on, turn the power off, and in the end, when it's happy, it'll allow you to proceed. I was saying to you, it's almost fully automatic in that once everything is up and running, the only intervention we have is we have to enter the physical transfer pressure being generated in the pump. And they just give you this digital display up here, and that's the internal pressure of the pump. And the bench will automatically go to A speed, and the pressure will come up on screen what it's meant to be between the tolerance. And if it's in that reading, you can punch it in, hit the go button, and then that's it. You can walk away from the bench. And Delphi injectors, if it goes through and fails, you can't start from that point again. You have to rectify the fault, go back to the beginning, and run through the whole process again. Having a big think and should be right in a minute. Some people think they can buy this processor and just fix their problem on the vehicle. The pumps are expensive. They vary anywhere between about $2,900 and about $3,500 for a recoat pump. And people will scan the vehicle and it might come up saying spill control solenoid failed. Well, the solenoid goes on the end, which is part of this processor, and they just want to buy that, but you can't. They don't seem to understand that as a component it's useless, it's dead until it's written. Sorry, but anyway, John's got it set up. He's got the dial indicator zeroed on the base of the cam inside. You'll see before you do, John. As you turn it, it's following the cam profile. Now, at certain positions, and you see here up on screen, it's got start points and it's got datum points which represent the number of cylinders. And if it's a 4-cylinder, you'd only go to 5. If it was a 6-cylinder, you end up at 7. And they only have that many points because they come back to the beginning to double check again. So there becomes actual 7 inputs. So John will rotate it to a position which is normally 1 millimeter. and then record that in, then it'll write its actual position in degrees, its angular position, so that the processor on the pump knows where the beginning injection is on every firing cycle, and it can correct for it. You'll see there that it's incrementing. Well, 6-cylinder. I'm assuming, is it 6 or 4, John? 4. It'll be every 90 degrees, and just comparing the readings for those positions, because we're always going to 1 millimeter of lift. If the cam was 100% uniform, you would have 90-degree increments here, but there's just subtle differences in the cam, and it's just writing it into the ECU. Yeah. So once that's written, it's happy, then it allows us to go to the next process, which is mounting the head in and connecting it up. Again, it asks us to go through a step. This turning on and turning off, I think it's just initializing the ECU so it knows it's back like a reset, and it will write it. And we hope it's happy. I'll let John go there. If you want to have a look at the other pump, that common rail injectors are still going. You may see something happening there.